So what happens here, when we're dealing with systems of inequalities, ladies and gentlemen, all the rules for graphing one inequality on a piece of graph paper hold true. Nothing changes. We still have to identify whether or not we have, what do you call them, solid or dotted lines. We have to identify whether or not we have where our test points are. We have to find out how to plot our stuff and shade. And I had a bunch of graph paper lying around somewhere. Yo, well, we'll do it. We'll be all right. I know I have some.
I brought something home.
Oh, like the giant stack of graph paper that I had lying out a second ago?
Wait a bit.
Because I swear I just had. I had a couple hundred sheets of it lying right here. Oh, is it really? How much graph paper do you? Oh yeah, that looks exactly about the most I got.
I didn't take it today. I've accumulated it. But I need some you back.
Grab a couple and pass them around. All you need is two, one for some notes and one for the homework. I know there's more lying around here somewhere.
Well, I'm gonna request mine back once you find it.
There is. Someone's stealing graph paper on me. Where did I put it? I swear I had it. Whatever. Anyway, you can always rough draft it too. I can see you're in a hurry. So what happens here is we still go ahead and we set things up like we would normally. When you're doing these systems of inequalities, one thing I would suggest, two different colors. Use a pen and a pencil. Use color pencils if you want to make stuff go through. We do everything like we did before. So for this first equation, I'm going to solve for y. I get negative y is less than or equal to 2 minus, less than or equal to negative 3x plus 2. From there, I'm going to go ahead and multiply out by the negative 1 to get y by itself. And remember, when you multiply out by a negative, you flip the sign, and I get that. Y is greater than or equal to 3x minus 2. And then from there, we go ahead and plot like we have in the past. We start at negative 2, we walk our slope of 3. Just like every other time, you would also now ask, is it a solid or a dotted line? Solid one. And then we have to check our test point. Do I go through the origin?
No.
So, I go back up top to the original equation. What's 0 minus 0?
0.
Is 0 smaller than 2?
Yes.
Yes. So it's true. And there's my shade. Yes, sir.
Could you do the
Cover and solve? Absolutely. The only thing is sometimes with cover and solve, well, the negative isn't so bad because you cover and solve it out and you get one. Exactly. But you wind up sometimes with you'll get that fractional amount. So you get 2/3. So it's kind of iffy. Sometimes it's a little bit easier to go ahead if you know that you're not going to get a fractional amount just to plot it out. Because you also, yeah, for the next one, sure. But remember, you also want to make sure you extend the line all the way through. Don't just plot the points on the axis because there's going to be, you might need to find a different shade region. Okay? So like he suggests, you can do a cover and solve for our intercepts. If I cover up the 2x, my y-intercept is 2. Do you agree?
True.
I cover up the y, my intercept is 1. Now, when I want to figure this out, I do also believe in my slope that is negative 2. Do you agree? To connect those two? So I can just make more lines, or more dots, I should say, and go the other direction as well. Do I connect those, or do I dot those?
Connect.
I connect those as well, because it is a less than or equal to.
What's you can just cover and solve?
Absolutely. But be careful, though. You make sure you extend your lines, because you need to try and find your shaded region areas.
You can't just like, because of the angle, you can just guess.
Try and fill in a couple. It's not going to kill you. And then lastly, is 0 plus 0 smaller than 2?
Yeah.
Yeah. So here, I'm shading this way. And you wind up with a shaded region that's shared in here. So that basically tells you the following. Oops.
Mr. Mayor,
Yeah,
can you tell me how you run the graphic please?
what's that?
This, I'm not getting a graphic really fast.
Oh,
I can
do you have more? Do you have the other stack of graph paper by chance?
You are. That's really that Well, now I don't actually have any graphics.
So what happens here is this shaded region where they're shared shaded region, what you found now is that every point that's within the shaded region that's overlapped is a true statement for both of those inequalities. Okay? You're finding a boundary. And this really leads, this boundary area, this shaded region, leads us really into our linear programming stuff that we start tomorrow, 3.4. Okay? As we get through some of these things, you will start to find out that it is sometimes easier to do cover and solve versus the other one. It depends on how they set up the problem for you. Yes, sir?
Do you leave the other stuff shaded too?
Yeah, that's fine. Because you're looking to see where the overlap is. And as we get into tomorrow, you will start to not shade as much. You will learn how to shade just a specific shape. Okay, and that's what we're building towards. Yes, sir?
So, does the only part that count is the intersecting filled in?
Yes.
So the other parts don't matter? Like,
Correct. Because if I picked a point here, you know, if I said it was at 0 and 7, it would not be right. It would be only right for one of those inequalities, not for both. I'm looking for when it's in both of them to become happy. Because then that's a solution set for both inequalities. And eventually we're going to have 3 or 4 of these things that we'll shade on one piece. Eric.
Is it possible for it to be true and the penalty on the else side, or is it just not? Is there like a situation where that could happen?
No, I don't think so.
Thanks, guys.
Let's try another one. I found that by lightening this up a little bit, you kind of, it's a little bit easier to see if I don't have the grids to start. Now in this case here, I've got y is greater than or equal to negative 3x minus 1, and then the other graph is y is less than x plus 2. I don't have to worry about doing any covered and solve or anything like that. I just go ahead and plot and walk my slopes like I would normally any other day. So you start the first graph at negative 1 and walk your slope at negative 3. So you go down 1 right 3, or down 3 right 1. And remember, the opposite of down and right is up and left. And then you ask yourself the question again. Do you feel lucky? Well, do you? Well,
Oh.
I just thought of that just now. I haven't used that joke at all today.
I don't get it. I was thinking like,
Anyway, is it solid or dotted? Let's just go like that.
it's solid.
Solid as a rock.
What movie is that from?
Dirty Harry. Clint Eastwood movie. It's like 5 shots for 6. Quite frankly, child confusion. I don't know either. But I have a loaded 57 Magnum, the most powerful handgun ever made. You have to think of yourself. You feel lucky. Well, do you? Punk. Yes, I did quote the movie. It's a bad movie, but that's the ending scene, and I think I might have given it away. Spoiler alert, sorry.
What happened?
Once again, test it. Does it go through the origin?
No.
Nope. So is 0 larger than negative 1?
Yes.
Yes. So I shade towards 0, 0.
Could we wait to shade so we can just shade it?
If you like, that's fine. That's fine. And then I do the next one, x plus 2, start at positive 2. And this one's going to be a dotted line because it's just a less than problem. So I'm just going to do that because it worked out nicely. And is 0 smaller than positive 2? Yeah. So then I'm shading this direction. So what he was saying is, can he wait to figure out where he wants to shade in the overlap? And that's fine, because if you wanted to do that, you start to sit there and go, okay, I know that's going to be positive, or it's true going this direction, it's true coming this direction, so you want it just this shaded region. Okay? And that's fine. If you do it that way, no problem. Yes, sir?
Did you ever have two parallel lines with the shading going away
Yes.
from
And I think I have a homework problem like that tonight.
each other?
What he's asking you is this, and this question came up earlier today as well. If you've got two parallel lines, you could have shades going the opposite directions.
So nothing's true?
Correct. There's no overlap.
That's like so inseparable.
Sure. Or what another one that's going to happen is this. Lighten this again. The only thing that's changed now is that I put 3 inequalities on here. You agree? Now, do you want to solve that third equation for y to get its slope-intercept form? No. What are you going to do? Quick graph. So let's start with the quick graph first. What's your x-intercept when I cover that up?
Let's go with 6.
6. What's your y-intercept?
A.
Good. So 6 and 8. When I connect them, is it going to be a solid or a dotted line? Ooh. I love the smart board. Now, does it go through the origin?
I don't think at least it doesn't.
All right, what's 0 plus 0?
0.
Is it smaller than 24?
Yes.
Okay, so it's shading towards the origin.
I know right where this is
What line
gonna
is
go.
it?
I did this one first.
Okay.
Okay? Because now
Right, it's a triangle.
it's a triangle. Because it's looking for what quadrant?
It's looking for the first.
Looking for the first quadrant. Because it's asking you for all numbers that are greater than, or for x values that are greater than 0. That's all the numbers going this way. Okay?
But it does cut you off.
And it also wants all the numbers that are larger than greater than 0 for y. So this region is bounded by a triangle.
It's dangerous.
Yes, ma'am. Yep. Well, it's not just the whole first quadrant, because if you look at this another way, it was x is greater than or equal to 0, y is greater than or equal to 0, 4x plus 3y was less than or equal to 24. That was the then, right? By it being x is greater than or equal to 0 and y is greater than or equal to 0, do we all agree that's first quadrant?
Yes.
Yeah. So if I see that now, I'm going to do a graph by hand. And here's the reason why. I know it's a first quadrant problem. And I know that that third graph, I can do my intercepts. We said it was 6 and 8. And I knew it was going this direction. And then I also knew, since it was first quadrant, that whole first quadrant's being shaded. But where does it overlap with this? It only overlaps with it in that region. Okay? Now, I also know that I have 3 points of inflection, 3 places where the graphs change, where it changes. And we can find these ordered pairs. What's the ordered pair here? 6, 0. What's this one? And then what's this? 0, 0. Okay? Now, for $1 million, this up a little bit here. We'll call this A, we'll call this B. What's the distance of AB? $1 million.
Triangle AB. You gotta use the distance formula if you want. Alright, 8
A squared, A squared, 10.
10.
How much?
10.
10. I think you were first. You win $1 million. The triple.
Oh, that's not what I did. I did Pythagorean theorem.
Because this is 6, this is 8. Yeah, 3, 4, 5.
Pythagorean theorem.
Easy, at least.
Air 5 for paying attention.
I didn't know. The area is.
So what happens here? What happens here is that we are going to be working with getting into the general style graphs. We are going to be able to find boundaries and endpoints, and this is kind of like the skill set that I want you guys to be able to do after you go through the homework tonight, to be able to do this without a graph paper. Today you'll have graph paper to doodle on this, because everything should work out. Yeah, there might be an odd, or not odd, but like a weird intercept, like a half or something. But for the most part, I want you guys to start to get the idea of, I can do it like this, because tomorrow in 3-4, when we're doing our objective functions, we want to maximize or minimize a specific area. And this is where all this stuff leads us. So let's try a couple more. Try this one real fast, see how you do.
Oh, these are so terrible.
Does anybody have one sheet of that graph paper that I can
Yeah,
have? So I
yeah,
can-
I have 4.
Can I have one so I can make more copies of it? I don't think we need it anymore for, thanks.
I never realized you could make that.
There are these crazy machines out there.
So convenient, at least.
Sometimes, yes.
Sometimes I get at least maybe. That's what the good thing is. None of them go through the origin.
Exactly. It's always nice. But remember, even if it does go through the origin, who cares? Pick something that's not on the origin.
Yeah, they did, I mean.
5 and 0.
Student from zero. True.
Oh, you. No, it's a parallelogram that goes up infinitely to one side. Okay. No, it's not quite a parallelogram. It isn't actually. I didn't make mistakes.
So x is greater than or equal to 0, which means it's everything going this way.
It's like an infinite parallelogram. Yeah. You got this ball.
Now, infinite gram? Stop making up words. The other one starts at -1, walk up and right, up. 2, right 1. Is that a solid or a dotted line?
Let's go with the dot.
Okay. Is 0 larger than -1?
Yes.
And then the other one is at +3, same slope.
Oh.
Same idea, dotted out. Is 0 larger than 3?
Not even close.
So that one's false, so it still comes up the same direction.
This is so tricky, so it's just that little.
Yeah,
area up
what
there.
happens here, the only space that's the overlap is here in that spot. So you get that little, you got you've got a defined edge at x equals 0, and then a dotted line at the one, what is that, the 2x plus 3 inequality, okay?
Wait, so it's not triangle, it's just like
Yeah, because there's no top to it. There's no top to it. It's an infinite ceiling, okay? And you will, so what? So what happens here, sometimes you're going to have something that's closed off, sometimes it'll be opened up, sometimes it's going to be bounded out by a parallelogram, a rectangle, a triangle, anything. All right, depending upon what your problem looks like. Let me give you one more.
Do we have homework tonight at least?
No, why would you ever have homework?
Yeah, that was our case. What, wait, are we using graph paper for our homework?
Yes.
How many questions is it?
How many graphs are on a graph paper?
9, so, no, 12, 12, so we have 12 questions. I think.
No, I think it's 4 o'clock.
Maybe if we use 2 graphs for 5
3 days in
questions.
school this week divided by 12.
Once again, if you look at this problem, you've got x is greater than or equal to negative 3. What kind of a line is x equal a number? It's vertical. What does this go through? Negative 3. It goes through negative 3. And which way are numbers greater than negative 3? Going to the right of that line or to the left of that line? It's going to the right. So here's what I'm going to do. I'm just going to put those 2 arrows out there for right now, because I don't know where any of the other overlap is yet.
I like that.
Okay. Do the same thing with x is less than or equal to 4. Still, it's a solid line that goes through, it's vertical through 4.
Such a good kind of interesting. Robin thing.
And I know that it's got to go to the left, because I need numbers that are smaller than 4. So right now, I have this opened top, opened bottom space between negative 3 and positive 4. Do you agree on that? Okay. Now all I have to do is just find out the other one. Y is less than x plus 5. So I start at 5, and I walk my slope of 1. And I'm not going to continue it past those 2 uprights because it's already bounded me within them. And is that going to be a solid or a dotted line through there? Dotted. It's dotted, and I can leave it just like that. Yes, ma'am?
where do you start?
I started at 5. It's x plus 5. So I started at 5, walked my slope of 1, and I stopped at my 2 uprights because I'm bounded between negative 3 and positive 4 for my domain. So my domain is bounded. From here then, is 0 smaller than 5?
Yes.
So it means all I'm looking then is all the region between these 2, all the way up to here. That's the overlap.
That's so cool. Oh, yes,
You can get some pretty cool graphs through this stuff, okay? Tonight, what I'd like you to do, give you a little time to start on it, is section 3.3. I believe it's page 160. Let me get the right numbers out here real quick. It starts,
Page 160.
yeah,
Number?
36 through 44,
Alright, 36, 44, let's take
and then 48 through 50. That gives you 12 problems. Okay? I think that was the get page. Let me double check. Yeah, 160.
If you're lucky, I guess.
Oops.